This video is going to be on how to find a slanted asymptote, slant asymptotes of a rational function. A slanted asymptote doesn't occur all the time. It only occurs in a special case. And so I'm going to give you an example of when a slanted asymptote would occur and why it would occur. And so take, for example, a rational function f of x equals x squared minus x minus 2 all over x minus 1. The reason a slanted asymptote is going to occur in this problem is first because it does not have a horizontal asymptote. So first, it doesn't have a horizontal asymptote. And the reason it doesn't have a horizontal asymptote is because the degree on top, oops, spelled that wrong. Because the degree on top, which is a 2, is greater than the degree on bottom, which is a 1. But notice in this case that the degree on top is 1 more than the degree on the bottom, so there is no horizontal asymptote. But in this special case where the degree on top is 1 more than the degree on the bottom, there will be a slanted asymptote. The way to find the actual slanted asymptote is to just divide. So this little bar right here means to divide, so you're just going to divide. And since there's two ways to divide polynomials, you have a choice of long or synthetic division. And as long as it follows the rules, synthetic division usually works best. So in this case, since we have just x minus a number, we can do synthetic division. So 1 would be on the outside, and then on the inside would be the coefficients 1, negative, negative 1, and negative 2, and then we divide. So bring the 1 down, multiply on the outside, which is 1, add down, which is 0, multiply again, which is 0, and negative 2. The nice thing about the slanted asymptote is first you don't worry about the remainder, and it doesn't matter. And then after that you put the x, and then 0 is our constant term, so the slanted asymptote is just y equals x. And so if you're looking for a slanted asymptote of a rational function, really all you have to do is divide. And then you can come back to your function and find the rest of the pieces of information, like the vertical asymptote or the x-intercepts or things like that. So let's take a look at how we might graph a slanted asymptote and what it would look like for you. So for example, let's take this guy. We have this graph here. Let's take the function. Let's say the function is y equals x squared plus 6x plus 5 all over x plus 2. So once again, it doesn't have a horizontal asymptote because the degree on top is 1 more than the degree on the bottom. And it will have a slanted asymptote, so we can do the synthetic division. So looking at the denominator, negative 2 would go on the outside, and then 1, 6, and 5 would go on the inside. Bring the 1 down, multiply by negative 2, which would be negative 2, so 4, and then negative 8, and then I'd get negative 3. Once again, the remainder does not matter. And so my slanted asymptote would be at y equals x plus 4. Now in my class, the way that I ask students to graph asymptotes is I ask them to use dotted lines. So slanted asymptote, you're going to graph it like you would a normal linear function. So 4 is my y-intercept, then the slope is up 1 over 1. And so I'm just going to make a dotted line, and this is going to actually be, right, a slanted line that the graph will approach but not equal. It will approach it as it goes to infinity, but it will not actually cross this dotted line. Next, you can find things like the vertical asymptote, which is at x equals -2, would be the vertical asymptote. So once again, I ask students to draw a vertical line dotted, and that would be your vertical asymptote. And then from there you can find points in the function. X-intercepts would come from the numerator. You could set that equal to 0 and solve it, and I think it would be something to the effect of -1 and -5 seem like good answers there. And then you could keep going, and so as this thing curves, you'll end up with a nice graph. And so that's how you find a slanted asymptote. You just divide, and so y equals x plus 4 would be the slanted asymptote in this problem. Alright, have a great day.